Okay. Right, so I'm going to talk a little bit today about the Moonv6 project, actually. I'm going to talk a bit about what it is, the testing that we've done, and some of the future stuff going on. Really, this is just to heighten the awareness of the project and kind of a call for participation. Moonv6 is led by the North American IPv6 Task Force, and it's geared to execute deployment of testing IPv6 technology. A number of government agencies, as well as academics such as the University of New Hampshire in particular. They're kind of like the hub of Moonv6, really. As well as service providers and vendors all take part in this project. A number of test items are determined by the operational requirements of service providers and government agencies, and everybody kind of gets together and composes various test plans. Here's a map of the Moonv6 network as it is today. You can see it's a lot of extensive connectivity here. DREN, Internet 2, MCI, May East and May West in particular. It's a really great environment for us to get some real world kind of testing going on. Definitely an extensive network at this point. So going back a bit to the phase 1 testing, some simple routing protocol tests were conducted, OSPF, BGP4, in native and dual stack modes. Some common network apps, DNS, HTTP, FTP, so on and so forth. Neighbor discovery stuff was touched on, as well as some of the transition mechanisms. Everything seemed to work pretty well there. There was some limited testing of security and advanced routing protocol features. And I should mention two things here. In phase 1, the primary testing was conducted in the UNH lab. And secondly, all the results for all the stuff that I'm talking about, all the testing and everything, details for all of that are available at moonv6.org, and I'll have that URL at the end. In phase 2, then, a fully operational network, V6 network, was established. UNH obtained a unique AS and started peering with AT&T and Internet 2. And really, the testing involved phase 1 items, just more refined and lengthened in terms of the testing period. So some significant convergence testing was completed with OSPF, BGP, and ISIS, and some QoS and multicast proof of concept testing. And in multicast here, really this was just a single network segment in this particular test, so no routing involved really there. Also some firewall functionality tests for phase 2. In 2004, in November, some additional testing was conducted with routing convergence, some more firewall functionality. DHCP and DNS testing had some deeper testing there. Also, a couple of demonstrations, VoIP and iSCSI, were conducted in November. And then most recently, the April application demonstration, which is where I personally got more involved. What we basically did was provided some transport for this demonstration. May West hosted some applications. In particular, France Telecom provided an e-presentation, and May West hosted that. Panasonic also offered up some web-enabled cameras for some of the testing as well. Some of the network details, MCI provided an OC3 to UNH, which connected them to May East, and enabled us to get some peering going with AS816, which is MCI IPv6 test network, as well as AS6066, which is a research network that's out of May West. And then Lucent provided the DNS infrastructure for all of that. Here are a few pages to take a look at regarding bits of information on the testing and whatnot. One thing to note here is that you're going to need Firefox for this particular syntax. So for the e-presentation, unicast testing was completed and went fairly well. The multicast testing being performed right now, what we did initially was build a very simple multicast network spanning the country with just a single RP and doing static RP, basically just to provide a conduit for the multicast application testing. So moving forward, what we're going to do is get into more interesting things, with really test the multicast network side in and of itself in more depth. Some additional testing has been conducted by some other MCI engineers. IPv6 transition with GRE tunnels over in MPLS core has been tested. Additional testing of dual stack and native scenarios, so various routing protocols there, BGP, ISIS, etc. Some scalability and convergence testing was conducted as well. And the results of these tests are due out in, I suppose, about the end of the month. So they're not quite available yet. Some future test items, routing again, but more on the QoS measurement side of things coming down the pike. Firewall, looking to get into some attack scenarios, as well as implementing some routing policies and seeing what breaks there. Some emphasis on voice over IP in the next round, transition mechanisms, always going to be some emphasis there, as well as pretty major emphasis this next go around on e-conferencing and e-learning. So again, the multicast stuff more in depth there. Under Moonv6, the organization in and of itself has really lent to some progress in IPv6 implementation. But more applications are really needed for testing. So any ideas that any of you have at all, please bring them out to us, and we can hopefully get something working there. We do expect more participation from enterprises and government agencies in the next phases, but we definitely do need additional volunteer resources. So this is kind of a call for participation as well, like I said earlier. If you do want to get involved in the next round of testing, which is going to be conducted in August, you should contact Moonv6 by May 31st. And to do that, just go to moonv6.org. That site will give you instructions on who to contact and how to get involved, as well as the detailed test plans and results that I referred to earlier. And that's it.
You have questions?
One amusing comment here, you're putting up IPv6 URLs, and here we are at a network forum where are we even able to resolve and make use of IPv6 URLs?
Yes, I tested them yesterday.
Okay.
Sorry about that.
So this is something where maybe we can start the ball rolling as a community here and start saying, hey, let's not just talk about IPv6 in theoretical deployments or testbed scenarios, but start using it in real practical applications like that. Thank you.
Absolutely.
I'm sorry, we're done with the questions.
Hi, Bill. How are you? So just to follow up on that, since there is IPv6 native, or not native connectivity here, but there's IPv6 connectivity here, it would have been nice if you actually had stuff that would work in most of the browsers that we have, such as Safari and such on our laptops. The address in the brackets? Okay, excellent. Okay. But to also show off the DNS, that IPv6 DNS is important to work around the NX domain problems that some people had. In addition to that, what providers have you found that are doing native IPv6 on a global scale in this? Because the goal of this project is to promote the native v6, correct?
And transition mechanisms, yeah.
Yeah, so I find it a little bit interesting because majority of the providers have just a tunnel infrastructure to do all that, including the MCI network, which you're connecting to as well.
That's correct.
Whereas there's other providers out there which actually do have native IPv6 networks that either span regions or globally.
Right, yeah. Certainly Asia-Pac has a few out there, right? So.
Well, including here in the U.S., there's at least one major provider that I'm aware of that has a native IPv6 network that's global dual stack v4, v6.
I'm not aware of that. network.
Yeah, it's very
I'm sorry?
Hi, Medica Kaya from Double Shot Security. One of my major comments, or my hope would be that Moonv6 would concentrate more on IPsec testing, since IPsec seems to make IPv6 inherently more secure, and I find very limited testing of that.
I would suggest contacting us and getting involved. That's myself.
Apparently you have a question coming in from somewhere else. All right, well, thank you very much. Steve, get yourself up here.